Today's talk is going to be a bit different. I'm the CEO of Deephaven Data Labs, but I don't intend to spend any time talking about our data engine here at Deephaven. Neither the one we're evolving in the open for and with the community, nor its big sister that we license to enterprise. Instead, this talk is about people, software in the service of people. I hope you see this as a conversation. I hope you see this conversation as an opportunity to think about the ways people interact with the software and systems you build and simply reflect on them. If my kids were here, they'd say, "Wow, Boomer, that's a big number." I've spent 27 years on Wall Street at the intersection of trading, software, and people. In 2005, I was the founding CEO of Walleye Capital. Yes, that ugly fish there. Walleye Trading is a $4 billion quant fund of 200 people that work with data all day long. Nowadays, instead of running portfolios and risk, I run Deephaven, an open source software company, particularly focused on real-time data at scale. You only come to this conference if you care about huge data sets, dense feeds, and the hardware and algorithms to make sense of them. But please join me in taking a moment to recognize that in regards to data, people also matter. Their eyeballs and their fleshy little fingers banging on those physical keyboards matter. People's interactions with data remain important, both in seeing it and affecting it. For the sake of time, I'm going to make some assertions that I hope you can agree with, enough to let me keep going. People are impatient and want the results now. That's number one. People need to both see output from and be an input to data systems. That's two. And lastly, tables are intuitive for many people to work with. When I say tables, I mean it in the purest sense of the word, just rows and columns with data in cells that you can manipulate in a variety of ways. If we can agree on those things, then the only controversial point on the screen is my assertion that it's both appropriate and helpful to treat people as first-class citizens of your data systems. Treating their experiences as a peer use case instead of a less important nuisance that must have its own way of doing things will yield big benefit, I assure you. I intend to map the soft human requirements we just outlined to something closer to a software spec. Then I'll quickly survey the potential relevant open source technologies. I'll describe the shortcomings our team found in contemplating those solutions. And finally, I'll discuss some work we've done in open source to fill the gaps. Let's roll. At a high level, I'd like us to center around three words: browser, table, and backplane. In this context, when I say table, I don't mean what's painted on the screen, but rather the computer science object that makes it all go. I use the term backplane to describe a software communication layer for all producers and consumers to share. Note the word all, and remember we intend to treat people and headless apps as peers. For the solution to be valuable, packaging and client processing must be efficient. Think of how Google Map UIs are able to support rich, interactive experiences as you navigate your surroundings. The client and server are efficient in knowing what data to send, and it's all purposefully processable in very quick fashion. I can see there are a few choices for your front-end tech, and I see no reason to start a religious war from here. So I'll simply suggest that though they're certainly imperfect, particularly in ways I'll touch on later, I hope many of you can agree that for portability, discoverability, collaboration, and many other reasons, browsers are a good choice. And then I'll just move on. My grandma didn't like swearing, but she'd tolerate it as long as it was infrequent and it had a point. But she thought the word suck was vulgar. So I'm really sorry, Nana. For a table object to be valuable, it needs to be dynamic. If yours is static, well then, Nana and I think it sucks. Dynamic exists in two ways. First, in regards to the data itself. Data needs to update in real time. You're all in finance, so I'm sure you agree. Second, dynamic relates to the client's ability to inherit a table of any size and schema on the fly. Oh, you want to see that table from over there? Poof, voila. We're not going to wire up a new REST API for the thing. Imagine a new column being added to a table server side, or a person changing their pivot view with aggregations on the back end. Clients need to support these experiences. Finally, a quick word about the other big player in GUI space. We see widgets simply as visualizations and interactive experiences stapled on top of tables. We want all pubs and subs to share the same concepts and methods. Just plug right in and interoperate. This both keeps costs down and allows us to innovate quickly. Some services on this backplane care about throughput. Others care about latency. People in their GUIs care about consistency. They want, 100 millisecond refresh rates, but they want it consistently. It's a lot to get right, and it has to work in both directions. Controlling throughput and latency means that client applications should be able to tell the backplane their requirements and limitations, essentially to say what parts of tables the client wants to receive and at what frequency it wants updates. Further, efficiency implies minimal copying and transformations. So the data needs to be both drop-in ready for GUI tables and efficiently packaged for non-human, low-latency consumers. On the screen are some candidate technologies for real-time data transport. In regards to underpinning our backplane, I want to simply dismiss the considerations on the left out of hand, without much discussion. Apache Flink, Spark, Storm, even Beam are data engines, not data transports. They're processing plants, not railroads. The three on the right, however, are modern candidates to underpin the backplane we've been discussing. ZeroMQ and Kafka manage messages in a stream, guaranteed to be ordered, and the ordering happens within a grouping called a topic or queue. Platform scale fan-out, persistence, and fault tolerance are provided by central services and agents. Kafka and ZeroMQ both transport whatever blobs you want. Sure, those blobs might have a name like Avro, JSON, or Protobuf, but the transport makes no claim of knowing anything about it. These are sturdy railway cars and solid train stations, but they can't tell you much about the loads that they're carrying. Apache Arrow isn't like the other two. It's not a message queue. Apache Arrow provides efficient sharing of in-memory column-oriented tables across disparate applications with zero copy. Flight takes Arrow and moves it over the network. It has a wire protocol. Flight is stacked on gRPC, which Google developed for connecting mobile clients to back-end services, but is now widely used as a transport. To minimize copying, Flight uses flat buffers, an efficient cross-platform serialization library first developed to help Facebook speed up its Android client. These are strong technologies, but here's the important distinction. Unlike ZeroMQ and Kafka, AeroFlight knows exactly what it's carrying, and that something happens to be a table. On the left, you see an itemization of the requirements from the last few minutes. Unfortunately, on the right, there are a lot of no's. Yuck. It's clear both that any selection will be a compromised choice and that we'll have to do some development. Here I'm going to make the case that Apache Arrow is the answer. Since tables are important, though nothing exists today, I'm happy to take on faith one could introduce a new table-oriented payload to Kafka. Maybe Arrow even. Hey, Mr. Kafka, instead of JSON, can you carry Arrow for me? This might work for append-only use cases, but even so, imagine the firehose case. At my core, I'm an options trader. Is Kafka going to give my JavaScript client the Oprah feed in a table? No thanks. It's billions and billions of records long. More threads and more topics aren't going to save me because the asynchronicity of topics can lie to my UI. Imagine sorting a big, updating table or a person scrolling around in a billion records. I'm going to be mighty pissed off at the producer and broker if all they can do is send me a fire hose of appends and I have to do the rest. If as a developer I hack it and create a new topic for each viewport so as to control my flow, I end up creating dedicated sockets, loose fan-out, and fault tolerance, and have to manage the messaging and serialization myself. So what's the point? Let's take a look at AeroFlight instead. AeroFlight has some promising qualities. First, it deals in tables. Second, it has an extra field for app metadata, somewhere you can throw some stuff, essentially to go along for the flight ride. Third, since Flight's built on gRPC, and since gRPC is invariably a streaming transport, it's reasonable to think, hang on, Flight 2 must support streaming. It turns out that it does, just in a static, batchy table kind of way. Then finally, as you may know, gRPC is based on HTTP2, which browsers can already speak. So it seems we have an open door back to those fleshy fingers. The Deephaven team has been writing open source software to extend AeroFlight so it can support dynamic tables, not just static ones, and to make Flight compatible with the browser. The work fell into 3 bits. 1, We had to find a way to describe table changes and package that information into those flight payloads I discussed. In that sentence, note the word changes. More on that later. 2, we had to add proper streaming. 3, there was work to do to make it all work with JavaScript. On that first to-do, I must confess that we cheated. We didn't invent a new data structure for table changes. We already had one. See, our data engine, the Deephaven query engine, performs incremental updates on tables. This makes real-time calcs fast and easy and minimizes network flows. That engine happens to have a format for communicating not just about tables, but about their changes, their deltas. So we just use that for this API as well. This structure describes 4 types of changes: rows that have been added, removed, modified, or shifted. On that last one, think of an insertion in a sorted table. Rows just shift. So we wrote an integration between this format and Flight's open metadata payload, and boom, Flight was ticking. We call this construct a streaming table, and the project is called Barrage. We needed to then add methods to Barrage for streaming. Nicely, Flight had a blank slate available for customization. It's called DoExchange. We added 3 new methods there. First, snapshot. This allows a client to request just part of a table, a subset instead of the whole thing. Second, subscribe. As you'd think, essentially make a server request to get a table or just a part of it, and then receive the deltas as they flow, pursuant to timing rules dictated by the client. Last, publish. This is the opposite of subscribe. Data flows from client to server with this one. The JS client was a hard problem. There were several bumps in the road to get Flight talking to browsers. They involved the need to use gRPC web, then its incompatibility with gRPC itself, believe it or not, browsers' inability to be a source of streaming data, the gRPC client's unhappiness with streaming binary data, and HTTP2's requirement for SSL certs, even for local host and within enterprise clients. With the help of the Envoy proxy from Lyft and an alternate OSS client written by the folks at Improbable Engineering, we solved all these problems. So where does that leave us? If you agree that data is dynamic, that tables are intuitive and important, that sharing a single transport system is empowering, and that people's experience with data do matter, then I hope the R&D we've talked about today is helpful. Barrage, the Aeroflight extension, is readily available. Spinning up an append-only or keyed last-by use case should be straightforward, and our dev browsers are happy to support you. The JS client is currently packaged with Deephaven, that data engine I mentioned before. Deephaven Core provides compelling capabilities for working with real-time data, by itself or in tandem with historical data. If you think everyone should be able to access real-time data, or that Python and Java user-defined functions matter, or that AI should work in real time, you might like Deephaven. Some big Wall Street names use it in the critical path of trading and operations. Lastly, we modularized our web UI. It's a pretty slick JS framework for dashboarding, and it has a high-performance grid that kind of rocks. For fun, we've demonstrated it supporting over a quadrillion rows. That's a lot. I hope your front-end teams consider using it, or maybe even collaborating with us. I can't thank you enough for your time today, and I hope you embrace the power of streaming tables, as I do.